Everyone, and welcome back. We are looking at letter E in the AP Calculus summer review packet. We're going to look specifically at all four of these errors or mistakes that are made in each of these statements. So we're kind of just like discussing them at least and stuff like that. Okay, so let's get to it here. So these are common mistakes that we tend to see students make, and it's not necessarily like, I don't want to like hate on people for doing this kind of stuff, because in some sense it's like it's good, you know, like we want you guys to think, you know, mathematically about things, but it's also important that when you make a mistake to understand the reason why you made that mistake and, you know, how to correct that for the future and stuff like that. So jumping right in here, we can see this situation right here, okay? And so the error that was made here, right, you can see that we took the quantity 3x plus 4 and we squared it, and the result was 9x squared plus 16. Okay, so where did this answer come from, right? Well, what happened here was they squared, the person squared the 3x, and that gives you the 9x squared, right? And then when you square the 4, well, that gives you the 16. The problem is, though, that this person forgot what the definition, what it really means to square something, right? So that's where you guys will be saved a lot of the time by really understanding the fundamental meaning of the different math that you do. And that's going to be true for the calculus that you learn too. You know, a lot of this is just going to be knowing your fundamentals, and the fundamentals will then guide you in the direction about which way you're supposed to go. So in this case, right, when you square something, what does that really mean to do? Think about that, right? What's 2 squared? Well, it's 4. It's because it's 2 times 2, right? 3 squared is 9 because it's 3 times 3. 3x plus 4 squared is 3x plus 4 times 3x plus 4, okay? Then we have to multiply, right? But this is a binomial times a binomial, so we can use FOIL here, but really we just need to make sure that this term multiplies with this and this, and that this term multiplies with this and this. Okay, so in other words, we're going to get 9x squared plus 12x plus another 12x plus 16. So there's the 9x squared, there's a 16, but we missed that middle term there. Okay, and so this simplifies to be 9x squared plus 24x plus 16. Okay, so again, this mistake here, it's not a necessarily like way off base though, because there is a situation where you can kind of do this, but it's not for multiplication. It's when you have sorry, it's not for addition, it's when you have multiplication. So for example, if we have 3x times 4 and that is squared, then that does equal 3x squared times 4 squared, like that. So in other words, when you take a product and square it, you can distribute that square over the product. Okay, and this would equal then 9x squared times 16, or, you know, if you multiplied it out, then it would be, let's see here, 90 plus 36, 126x squared. Did I do that right? 90, 6 times 9 is 54. Woo, 54, 44x squared. There we go. Anyway, this is the true answer then. Okay, now, number 2, okay, what's the error here? Okay, don't we... When we have a negative exponent, can we move that into the denominator? And the answer is yes, but look at this carefully here. What has a negative exponent? Only the x has a negative exponent here, okay? What you have right here is if we had parentheses around the 3x. Actually, no, that doesn't even make sense either. That wouldn't work either because we need a square there as well. So yeah, there's kind of like a bunch of mixed up things here. So truly, only the x is being raised to the negative 2. So this 3 should stay where it is. So it's going to be 3 times 1 over x squared like this, or if you like, 3 over x squared like so. Okay, because again, this is really 3 over 1, so it'll be 3 times the 1, and the 1 times the x squared. Okay. If we had parentheses around it like this, then it would be 3 to the negative 2 times x to the negative 2, which would be 1 over 9x squared like that. So, you know, again, this is not really gotten from any other kind of thing. So just be careful there. You know, really understand that notation too, because notation is also pretty crucial to understand. All right, number three. Number three is actually very similar to number one. Okay, they made a similar kind of error as in number one. A square root is a power, right? Remember that a square root is the same thing as x squared plus 9 to the 1/2 exponent, right? So it's very similar to simplifying like the 3x plus 4 squared. We cannot distribute the 1/2 power here because we have this addition. Okay, so what can we do here? How can we simplify this? Well, the answer is we can't. We can't break up this square root over addition, so we would try and maybe factor x squared plus 9, but x squared plus 9 doesn't factor, and so we're actually, this is just the best we can do right here, is the root x squared plus 9, and that's all we can really do. We can't really simplify it there. If this was the square root of x squared times 9, then you could say that that is equal to x times 3, okay, and really it should be, oh goodness, I want to say it's the absolute value of x times 3 there. Or just x times 3. Plus or minus x? Yeah, so plus or minus x, or the absolute value of x there, times 3. Well, in this case, well, again, shoot, because it's a principal root, we'll just say it's just x times 3 there, like that. Okay? And then for number 4, all right, our simplification here, you know, we can see that in the for this side right here, we see we have a GCF of x, so we can take an x out, like so, and then the temptation here is to say, oh, the x's cancel, and so we get this x plus 15 over 2. Okay, but notice there's a difference here. This x is multiplied with the x plus 15. This x is adding to the 2. Okay, so they're kind of relating to the rest of their numerator and denominator in different ways, right? This x relates to its numerator, it's multiplying with it. But this x is adding with it too. So it just doesn't quite work out to be able to simplify like that, okay? And we can't cancel the x's like this, okay? Now if we had an x times 2, then yes, the x's would cancel, okay? But that's not what we have here, right? So we are kind of stuck, and we have to just leave it as x plus 2 like that. Okay, and so again, there's no kind of like nice way to simplify beyond this, and that's the best we can kind of do. All right, so keep these mistakes in mind. There's other common mistakes that show up, and we will try to call those out for you guys ahead of time to, you know, help you out in these situations and things. But here are some common ones that we just see our students do. All right, I believe letter F is on Mr. Goff's. Let's see here. Is he the one that's supposed to do that one? Oh dear. Let's see. Calc. Oh, I have letter F. So I will see you guys for letter F, and that'll be my last one. Thanks, guys. Bye.